So in the last video we saved out our 3 squishy objects, the chocolate bar, the gummy worm and our jelly candy right here. And now let's load them back into our scene, arrange them in a nice squishy pile and then run the entire thing through Vellum to make them actually squishy. So first of all, let's bring them into Houdini, and for this again, since this is Houdini, we're going to use a node, and a node is a file node. And like the rob geometry output is the standard node of just saving some geometry out, the file node is the node to just bringing geometry back in again. So with a file node selected, let's click this little button right here. This opens up our file explorer, and let's navigate to a HIP file with this $HIP button. And then jump into our geo folder to see the single entries in here. Let's uncheck show sequences as one entry. And now I have my 3 squishy objects here selectable again. So let's select our first squishy object and let's hit accept. And if we put our display flag down at our file node, here again is our chocolate bar. Let's bring in our other 2 objects. So for this, let's create 2 more copies of our file node. Let's go to the file 2 and let's make this rather quick by just going into this file path and adding a 2 instead of a 1 in here. And now we have our gummy worm and our third node. Let's add a 3 in here and get this geo. Now after that, I want to move all of these geometries somewhere in space, and for this I can use a transform node inside Houdini. A transfer node basically allows us, if I wire this in, it basically allows us to use our transform gizmo that we're also used to here on the top level node, just in here as a standalone node. And I can copy this 3 more times, 1 for each of our objects. And in the end, I don't want to have just 1 of each, I want to have 2 of each objects in here. So let's just select all of them and copy them over like so. And I can copy by just hitting Alt on my keyboard and dragging. And finally, I have now 6 geostreams down here, and I want just 1 geostream. So in the end, I can use a node that's called merge to, merge all our geostreams together. Let's drop this merge node down, and I could go through each node and wire it in separately, but I can also select a group of nodes and just drag from them into a merge node to create a lot of connections all at once. And now all my geometries are on the same geostream. Now all our geometries right now are at world origin and therefore are also all intersecting. So I want to use those transform nodes to just arrange them inside a huge pile so they can later all fall onto each other and collide and be squishy and be nice. So for this, let's first of all start with our chocolate bar and let's maybe move it up a bit and then rotate it a bit like this. And then I go through the other transform nodes and arrange my other different objects as well. So something like this looks nice to me. Now our node tree has gotten a bit weird. So for example, right here we're saving our geometry, and right down here we're loading it right back into Houdini, and also we're creating 6 copies of essentially the same node tree right here. And as you might have guessed, this is not the most elegant way of noding inside Houdini. So why are we doing this here? Well, there are 2 reasons for this. First of all, I want you to get comfortable saving out and loading in geometry into Houdini, and also to get comfortable with those dollar variables that we used up here. So consider this a bit of an exercise. But also, right now, with our current knowledge of Houdini, this is also the most efficient and most orderly looking way to create a pile of 6 objects. Of course, inside Houdini, there are hiding workflows that are a lot more elegant, a lot more procedural than this. But for now, this is what we'll do to create a sort of neat node tree. And you can look forward to much more efficient workflows in the next episodes. But we have our copies now arranged in a column, and now it's time to finally simulate them. So Houdini comes with a lot of different simulation engines. And as you saw in the overview video, we're going to talk about them later. There's one simulation engine that we want to focus on first, and that's Vellum. So what does Vellum do? Vellum does basically simulate squishy objects, which is great for us here. So those might be soft bodies like we're going to use here, or for example cloth, or even stuff like hair, or even grains, so things like sand, and more recently, for example, even stuff like fluids. So to use Vellum, we again want to use nodes as always in Houdini. So let's hit tab and let's simply search for Vellum. Now again, as always, we get a ton of different nodes. And for now, as the most beginner-friendly way, I want you to look at these configure options right here that are sort of presets for the different objects that a Vellum solver can do. And in my case, in our case here, I want to use the Vellum configure balloon because, again, I want my objects to act like soft, squishy balloons. Let's drop this down. Again, this is a preset. This lays on a number of nodes for us. And the nice thing about Vellum is that we can also see the sort of logic behind what we're doing here. Because what is a balloon? A balloon is basically a very stretchy piece of cloth with some air pressure inside it. So this is what these two nodes are doing. Let's wire our geometry in. Let's set our display flag at our Vellum pressure. At this point, it's also a good idea to save our scene. So let's do just that. And now let's hit play on our timeline and let's see what happens. And as we can see right here, nothing happens. The reason why nothing happens is this is only the first part of our Vellum sim. And pretty much for all simulations inside Houdini, they're set up in two stages. We first of all have nodes that prep our geometry for a simulation, and then we have a node that does the actual simulation. And in this case, it is the Vellum solver. So let's search for Vellum solver, this node right here. And let's wire in all three inputs. And right now I'm on frame 43, and Vellum tries to simulate until frame 43, which it has finished right now. So this is the reason I got a slight delay here. So for now, let's jump back to frame 1 and wire in the last input as well. Now let's put our display flag down at the Vellum solver and let's hit play again. And now we should see at least our different objects are starting to fall down and even start to deform a tiny bit. This is of course not very interesting, so let's jump back to frame 1. And one of the first things that we can do to make this interesting is to add a ground position. So a ground position is just an infinite ground plane for objects to collide with. Now let's play this again and let's see what happens. And now all our objects are falling on top of each other and are starting to act a bit squishy. Right now they're all smushed together pretty drastically and are not that squishy. So right now I want to start tweaking different things about my simulation. And with, again, most simulations and most parts of Houdini, if you take a look at the nodes, we're again bombarded with different settings that we can tweak. And again, as always, with this beginner course, ignorance is bliss in Houdini, as long as you know what values you can ignore and what values you can adjust. So let's quickly go over them. Starting with our Vellum solver, starting on the first tab, the solver tab, we have, first of all, these two parameters here that we can take a look at. These are the substeps and constraint iterations, and these are both parameters inside the Vellum solver that control the overall quality of a simulation. If we increase both of those values, our simulation will run slower, but also more accurately. With Vellum, the best idea is to start with the constraint iterations first and increase those, and if you still don't get the result that you're looking for, you can then increase the substeps and maybe also dial back the constraint iterations a bit to make your simulation run faster again. Down below we have the collisions, and in this case we mostly care about the ground position for objects to collide with. And we can also, on the third input of our Vellum node tree, as we can see down here in the text down below at this position, we can also wire in a custom collision geometry, which we'll do later. Also staying on the Vellum solver, we can move on to the forces tab. And in this area, we can tweak the forces that act on our objects. And in this case, this is something where I actually want to tweak something. I first of all want to make the gravity a bit weaker. Let's set it to a value of -3. And I also want to disable all friction. So let's set both of these values to 0 and uncheck both of these check marks to get rid of all friction in your simulation. Now, what you might have also noticed by now is that our timeline down here is doing strange things. We have this colored bar in here, and right now this is orange, but a little bit earlier this was also blue. So what does this mean? This bar in our timeline is the cached area, because later we want to be able to not re-sim every frame, but to see our frames in sort of real time. So again, every frame that we are simulating right here is cached to our RAM in our PC and then is played back from RAM instead of resimmed. Right now this is orange because I first of all did sim a bit. I did sim to frame 45, but then I went into my simulation and I changed some values. So this cache right here, which is still on a RAM, is not valid anymore. If I want to update my simulation, I have to jump to the very first frame. Now our cache is gone. And if I now hit play again, we now get this blue bar again, which tells us that we have cached our simulation and our cache right here is still valid. And our objects are behaving a bit more squishy at this point, which I like, but I maybe want to make them behave more squishy than that. So for this, I have to take a look at the settings right here on these two nodes. Now these are two of a whole range of nodes inside Vellum, which all add different so-called constraints on our geometry. And constraints are later in Vellum the thing that makes those things act like either cloth or hair or balloons in this case. And different constraints have different parameters, but there are some parameters that are always the same no matter what constraint I select. And these are both the stiffness and the rest length scale parameters right here. And for example, for a vellum cloth should both stretch and bend or resist stretching and bending. And therefore we have this stiffness parameter and this rest length scale parameter here, as well as on or bend. And the same goes for a pressure. Also here we find a stiffness and a rest length scale parameter. So what are those doing? So the stiffness basically controls how hard Vellum should try to, for example, in this case, keep the volume of air inside each object constant. So right now, this is set to a value of 6 times 100. So in this case, it's not that strongly encouraged to keep the volume the same. And if I want to, for example, make my objects more squishy, I can, for example, set this to 1,000,000. Something like this. And if I simulate now, my objects should act a lot more squishy, and I think they're doing this. And the same goes for a vellum cloth. So if I see that my objects or my cloth stretches too much, I can adjust the stretch stiffness, and if I think it bends too much or resists more to bending, I can adjust the bend stiffness as well. And the other parameter that we care about is the rest length scale. And the rest length scale allows us to scale the goal value that our stiffness tries to match. So for example, right now rest length scale is set to 1, so our Vellum solver tries to match the same volume that our simulation or geometry starts out with. But for example, if I set this to 2, then our Vellum solver will try to set the internal volume to double the value it starts out with, and therefore inflating our objects a bit. So let's set this to 2, and let's try this again. And as we can see, now our objects are also a bit inflated once they fall down. In this case, let's add a bit of inflation. Let's maybe set this to a value of 1.2, and let's leave the stiffness at 1,000,000. And on a Vellum cloth, let's leave everything at default. And I think I'm happy with the simulation result. So this is our simulation right now. What I now want to do is to make the simulation even more interesting, is to add a new collision object that is not just a simple ground plane. And in this case, I want to add a tube around my objects, and I want this tube to also even rotate so that you're just tumbled inside a tube, sort of like an hourglass clock or something like this. To create this, let's add a tube to our scene, and let's maybe ghost all our objects to adjust our tube to the right size. Let's increase the radius scale, maybe something like this. And let's increase the height to something like this. And let's also move our tube up so that all our objects are definitely inside that tube. Let's also increase the columns on our tube to make this more high res. And let's not forget to add end caps so our objects can't fall out. Let's wire this in. Let's go down to our Vellum solver. Let's go back to the solver tab and let's disable the ground position. We have our own collision geo right here. And let's sim this again. Let's see if this works. And yes, now our objects are all colliding with this tube. And to make this more interesting, again, I want to rotate my tube. And I could, for example, keyframe the rotation right here. But in one of the previous videos, we also looked at dollar expressions to animate stuff. And I want to do the exact thing here. I want to add in here $F to rotate our tube with our current frame. So now our tube is rotating and our objects are simulating in there. Let's also set the timeline to our preferred length for the entire simulation with this value right here. And I already set it to the value that I want for the simulation, a value of 96 frames. And with this done, let's maybe sim our entire timeline so that we have a cache for all of it. So something like this. Now, simulation right now is nice and squishy, but I think it does need to be a bit more dynamic. And I could go in there and just tweak parameters until I like everything. But what a sort of hacky way of doing this is, which I like quite a lot, is to just simply animate the timing or create speed ramps later on once we're done simulating, because then I don't have to re-sim again. I can just tweak the timing of my simulation to make things a bit more dynamic. So for this, I can search for time to get all the timing nodes that Houdini has to offer. And in this case, I think I want to use the retime node. And yes, this is the right node right here, because on this node, I can first of all wire in the leftmost output from my solver. This is my simulation geo. And on this node, I have this speed parameter right here. And this allows me to speed up my animation and slow down my animations. For example, if I add a value of 2 in here, now simulation plays twice as fast. And if I add a value of 0.5 in here, now simulation plays with half the speed. And of course, this is a value that I can animate. For example, say we want to have a quick start to our simulation. So let's set this to 2. And let's also add a keyframe by right-clicking, going to keyframes and saying set keyframe. And then we maybe move to the point where they're almost all colliding like this. Let's maybe go to frame 24 and set, in this case, our speed quite slow to maybe a value of 0.2 and add another keyframe, something like this. Let's play this again and see what happens. And now our simulation slows down. And I can also move and adjust this point in our timeline to get the simulation to slow down at the value that I want. Maybe a bit later, maybe something like this. Again, to move keyframes in our timeline, I can press Shift on my keyboard and drag to make a selection, and then press the middle click and drag to move my keyframes. Again, this is something that we talked about in the parameters video. And therefore I can adjust the simulation or the retiming to my liking. And I think this looks fine. And maybe right at the end, maybe around this frame right here, let's also again add another keyframe and move on to the very last keyframe and set this back to a value of 2 to make this again a bit more quick. And I think this makes our simulation a lot more dynamic. Now at this point you probably want to render what we're seeing right here, and rendering will be a part of a different set of videos in the future. What I want to show you right now is how you can simply export this geometry right here as an alembic and then open this, for example, in Blender or Cinema 4D. So to do this, what I mainly want to do is I want to isolate each of my objects inside its own geostream, because later in Blender I want to also assign a different shader to each object, for example. And for this I can use a very quick way. Let's also maybe get rid of the ghost flag up here. I can simply use a blast node. A blast node is the way of deleting things inside Houdini. And right now the blast node is set up to delete everything, but again we have a group field up here, so let's make use of this. And I can click on this arrow again right here to make my group selection. And I can select entire geometries by just double clicking on them. So in this case, let's say I want my chocolate bars, so let's just double click and shift double click on both of them to make the selection. Again, with my mouse in the viewport, let's hit enter. And then in here, let's say delete non-selected. And now I just have my chocolate bars. And you can again duplicate a node. Again, select different objects. In this case, our gummy worms. Hit enter and duplicate again. And select our last objects and isolate them again as well. Now I have my 3 different objects back. I maybe also want to subdivide them before exporting. So let's maybe focus on our chocolate bar here. Let's add a subdivide node after that, something like this. Let's also add this on other nodes and on my jelly candy, because this is a geometry based on triangles. I may also want to select under the algorithm on my subdivide node, open subdiv loop. This looks a bit nicer here. And now I want to write all of these out as different alembic files. And for this, I don't want to use the Rob geometry output that we used before. I want to use the purpose-built Rob alembic output. So let's drop this down, wire this in, for instance, here on a first geostream right here. And again, let's take a look at these settings. It's quite simple. We again have a save to disk button. that we're going to use later. Then we can set up what we want to write out in the end. Right now this is just set to a single frame, but I can set a frame range, and this grabs the frame range down here that we set earlier. And then we again have the file path where we want to save out. And in this case, I want to change things up a bit. Again, I want to start out from a current HIP file, but then I want to save this inside a folder called ABC for Alembic. And then in this folder, I want to create an Alembic that has the same name as my current HIP file. So let's add $HIP name again. And then after that, the name of our Alembic node. So let's add a point to separate all of this, and then $OS for the name of the current node. And then again, end with .abc. And we don't need a frame number in this case because an Alembic saves a whole frame range inside a single file. So this is the setup on this node. I can rename it. So for example, let's name this squishy _sim _1 and copy this and copy this again. And then I can, for example, select my first piece of geometry and simply say save to disk. And a small window will pop up. I get the progress on my save. And if I take a look at my project folder, this right here, I have a folder called Alembic inside here, and inside this Alembic folder I have the file that I saved out. And again, I can open, for example, a new scene of Blender, delete all my objects, and then go to File, Import Alembic. Again, navigate to my project folder, go to the Alembic folder, select my Alembic file, hit Import. Maybe zoom in a bit, and now I have the animation of my Vellum chocolate bars. And I can bring in my other two objects as well and assign shaders and add lights, and in the end hit render and hopefully get a nice looking scene. So this is it for this episode, and I'll see you in the next one. Until then, it's cheers and goodbye.